Welcome back to CS201 Walkthroughs. My name is Lukash, and today I want to talk about match in Homework 4. This is, I think it's your last problem in Homework 4. It can be a little bit of a doozy if you don't approach it right. So let's read through it together. It says match takes two Boolean expressions, expression and pat for pattern, and attempts to match the expression x to the pattern pat. That is, it tries to find a table subtable as in the preceding problem, such that substitute in pat subtable returns the expression exp. If this is not possible, it should return false. That was a little tough. I think basically what it's saying is that can we get expression to look like pattern, right? Or is it the other way around? Oh, can we get pattern to look like expression, right? When we run substitute in with pattern in some subtable, we want it to look exactly like expression. And this may seem tough. You might think, well, we have to deal with a whole load of cases, right? What if both are constants? What if both are variables? What if one's a constant and one's a variable? What if one's a constant and one's a BOR? What if one's a constant and one's a BAND? Right? There are something like, I guess there are like 6-ish things that it could be. It could be a 1, a 0, some random symbol, a BOR, a BAND, a BNOT. And if you try to match each up with the 5 other things, then you get like 30 possible conditions you have to deal with. I'm going to tell you that I think there are only 5 conditions you have to deal with. So let's walk through them. I think the first condition that you can, and I think they're all pretty doable too. Maybe I'll give a little advice on how to handle them. So I think the 5 conditions you have to handle are first, constant and constant, right? If both are 1s or both are 0s, you're good. If they're different, then you're not good. Pretty easy to handle. If both are BANDs, right? So BAND and BAND, or BOR and BOR, BNOT and BNOT, then what do? Well, then the arguments have to match, right? A BNOT doesn't automatically match another BNOT. It only matches that BNOT if their arguments can be matched, right? Remember that through all of this, you have to be keeping a list of entries that make up an environment in which they will match. You can do that by making an entry whenever you need to make an entry, and then append together whatever you get, return an empty list when you don't want to make an entry. For example, if they're both 1 and 1, both 1, you can return something like an empty list, right? This is true for the overall function as a whole as well, because an empty list is an environment in which 1 equals 1. You don't need to change anything. And then when you do need to write an entry, then you can just make it in a list. So what's this last case? Well, we haven't handled variables yet, right? I would argue this last case is variable and anything. So this could be this anything could be another variable, could be a BAND, BOR, BNOT, or it could be a constant. So in this case, why don't we have to worry about the other cases? Where, well, whatever this anything is, we can set the variable to be it, right? This variable can represent any sort of Boolean expression. And if this is a Boolean expression, or maybe I should write more specifically, any Boolean expression, but we know that the things being passed in are Boolean expressions by the problem specifications. So this is pretty easy to handle, right? We just set the variable to be it in an entry and append that, or I guess return that entry in a list. Return that entry in a list. What do you do with all other cases? I guess there's a 6th case, right? Or all other cases. No! We cannot match. Return false and cry, right? If we have constants that are different, if we have a BAND and a BOR, a BAND you cannot match to a BOR by changing the arguments, right? That's just not going to work. A constant you can't match to a BOR. Doesn't matter, right? And we're not going to worry about the case and like say that the constant is 0 and the BAND is something like A and not A. Technically, those are the same because not A and A is never true, 0 is never true. They are equivalent, but we're not going to say that you can match one to the other in this case, because if you'll understand why if you reread the problem specifications. So in all other cases, we just return false. Okay, once you've handled these 6 cases, it should work. If you have any questions, of course, come into office hours, email the CS201 help email, post on Piazza. Thank you for watching this video. Remember to like and subscribe, and I hope to see you in the next one.